A quadratic curve has its minimum point at 1, minus 2 and has a gradient of 5 at the point where x is equals to 2. Find the equation of the curve. Now a quadratic curve should be of the form ax square plus bx plus c. So the first thing I'm going to do is to let the equation be y equals to ax squared plus bx plus c. And of course we need to have enough condition to solve and look for the values of a, b and c. So if we look back at the equation or the question, we can see that there is one set of coordinate given where x is 1 and y is given as minus 2. That should be giving us one equation. And then if we were to differentiate this expression and if we were to substitute x equals to 2, we are told that the gradient is 5. So we could equate the dy dx to 5 and that should give you another equation. So let's look at how to solve this now. Of course, the first thing, because there is a talk of the gradient here, so let us differentiate this expression. So if I were to differentiate ax squared plus bx plus c, it's going to become 2 times ax plus b. Of course, the derivative of a quadratic equation would become linear. And then now let's substitute this. There is a word here, minimum point. That means the first derivative dy dx should be 0 when x is a 1. So first thing, before we use that condition, let us substitute when x is 1, y should be negative 2 into the equation of the curve. So y I am replacing with a minus 2 and x I am going to replace it with a 1. So that is going to give us a times 1 square plus b times 1 plus c. Of course, 1 square of 1 is a 1. 1 times a would be simply a plus b and then plus a c. And that should be equals to negative 2. So we have got the first equation. Now let us go for the second equation. Okay. So we are told that it is a minimum point at 1, minus 2, right? So that means when x is 1, the first derivative should be equals to 0. That means dy dx is equal to 0. So we can use this condition to get the second equation. So I am replacing the x with a 1 in the dy dx expression, and dy dx of course should be equal to 0. So let's equate it to 0, and then 2 twice of a plus a 1 is simply going to become 2a plus b equal to 0. So there we have the second equation. Now let us go for the third equation, because a, b, c, there are 3 unknowns, so definitely we need to have 3 equations if we would like to solve it. So this again is gradient is 5. That means dy dx is 5 where the x is equals to 2. So we can take x equals to 2 and dy dx is equal to 5 and substitute into the expression for the first derivative. So 2 times a times x value, which is of course 2, and I have substituted here, plus b, and that should be equal to 5. So twice of 2 is a 4. 4 times a would be 4a plus a b should be equal to 5, and that would be the third equation. So now we have got 1, 2 and 3 equations. Now we can start to solve, okay, simultaneously, or we can just use simply graphic calculator, and if we were to put in all these 3 equations, and we can see that the value of a should be giving us 5 over 2 or 2.5, and the value of b should be negative 5, and the constant c should be equal to half. So let's take the values of a, b and c and put it back into the equation. So therefore your equation is y equals to a, which is 5 over 2x squared, plus b, which is plus minus is minus 5x, plus the constant, which is half. So that is the equation of the quadratic equation.